Okay, so um, today we will be going through another way to check if something is elastic or inelastic collision. Now, this can be done when you go through relative speed of approach. Wait a second now. And there is some issue going on. Relative speed of approach and relative speed of separation. So we're going to do this. Now, please try to understand that this one, let's suppose you have an object like this. Irrespective of its mass, we need to understand that the velocity, suppose it's u1 for this object, and there's another object which has u2 speed. So, what we can basically say is that the relative speed of these before we approach this will be u1 minus u2. So this is basically before they collide. Afterwards, what happens is that this is this changes to v1 and this changes to v2. So with that said, we must understand that afterwards the speed is going to change like this: v2 minus v1. Now, so this, the first part is called the relative speed of approach, and this one is called the relative speed of separation. Then, defining the change. Now you can combine these. You can write that these are u1 minus u2 equals to v2 minus v1, like that. So you got to just remember this formula, and then you can apply it in different situations. For example, if u1 minus u2 is indeed equal to v2 minus v1, then we would call this as elastic collision. And if u1 minus u2 is not equal to v2 minus v1, then we call this inelastic collision. Like I said yesterday, elastic and inelastic means, like I said yesterday, elastic and inelastic means that the total kinetic energy before and after is not the same. Please write this. And if you have any questions, let me know as well. Okay. Hello, Caroline. How are you? Please copy this quickly, and then we're going to move forward. All right. Now, why this method is so important? I just wanna basically bring your focus into this. The importance of this method is that there will be two type of questions which we will be doing, and those questions come readily in paper 1 especially. So first of all, let's look at the type 1 question. Okay. So suppose they have given you two objects, x and y. One of these, which is going in this direction at 50 meters per second, and one of these is going in this direction at 30 meters per second. Okay, so this is given. Now, they would simply ask you which row is possible for two masses after collision for an elastic collision. This is one of those MCQs. They have given you a table of velocity of x, velocity of y, and then answers. So A says velocity would be 0, and this will be 20 meters per second in this direction. Okay. Then part B, answer B says 10 meters per second in this direction and 10 meters per second in the same direction after they collide. Part C says 20 meters per second in this direction and 0 here. And part D says 30 meters per second in this direction and 50 meters per second in this direction. Now everyone, please focus here. First of all, you guys need to understand that what they require is they require elastic collision. Elastic collision means, so I'm going to make a table out of it. Elastic collision means that the value of u1 minus u2 should be equal to v2 minus v1. This should be upheld at all times if this is elastic. So in the first step, we want to make sure, we want to understand that the signs are given to directions. Like for example, if I take this side as positive, I'm going to take this side as negative, then this will be positive, this will be negative. And for all of the parts, I'm going to do the same. I'm going to put positive signs whichever speed is on the right and negative signs on whichever speed is on the left. This way, when I'm ready, then I can put in the values because this formula is basically sign dependent. Okay. So now, step 2 is I'm going to check all the answers. You're not going to stop on one, but all answers. So let's see which one is right. So initially, u1 was positive 50 and u2 was negative 30. If you see, there's negative sign already, and then 30 is also negative here, so I put it like that, right? So because these two are fixed, so in every part it will be fixed, like 50 plus 30 is 80, so this is going to be positive 80 as well. This is going to be positive 80, this is going to be positive 80 on the left hand side. Afterwards, what happens is, in the first one, V2 is 20 minus 0. So because 80 is not equal to 20, which means this is inelastic collision. So this one will be 80 equals to 20. So you guys need to just compare it from left and right. Then 80, and this will be 10 positive minus, that would be 10. So 80 equals to 0 is inelastic, so I'm going to just cancel it out. Finally, the next one, check this, minus 20 and minus 0. So 80 is not equal to minus 20, so that would be 0 as well. Hmm? Sorry, I put it wrong this way, my bad. 0 minus minus 20. This was V2. Okay, so this will be wrong. Then 80 equals to, if you see this, 50 minus, and then the other one is minus 30. So it basically becomes 80 equals to 80, which means this is the right answer. And I'm just gonna pick this one. All right, anybody who could not understand this, please let me know right now. Ahmed,
Yes, sir.
good.
Sir, can you please repeat?
Yes, yes. Should I repeat?
Yes, step 2.
All right. So I'm just gonna do it again. Check this. First of all, what we did was we already have this condition given, and which means that this is U1 and this is U2. मैंने पी लिया बाकियों को दे दूँ इसका एक इधर हाँ. And this is V1 and V2, right? So these are the speeds. Our formula, like it says, which row is possible for two masses after collision for an elastic collision. For elastic collision, this formula, the right side of the left side of this formula should be equal to the right side of this formula. Okay, Fatma? Do you understand?
Yes.
Now, what you're going to do is first assign the signs. Assign the signs means if you take right side as positive, you take left side as negative. Now you see, this was on the right, so I put positive sign. This was on the left, I put negative sign. And then on the answers as well, I'm going to do this. This is the answer section. So 0 has no sign, but because it was towards the right, I put positive. This was towards the right, I put positive. This was towards the right, positive. This was to the left, so negative. And this was also left, negative and positive. Do you get it this way?
Yes.
Now on this side, well, these are the initial speeds. So V1 minus U1 minus U2. So U1 is 50 positive minus minus 30. So 50 minus minus 30 will give you basically positive 80. You agree?
Yes.
But whether I'm checking this, this, or this, I should understand that all of them have the same initial condition, which is given here. Understood?
Yeah.
So left side will always be 80. So I got to check which condition out of these four will give me 80 on the right side as well. So for the first one, if you check V2, we have to do V2 minus V1. We would do this, right? As you can see. So 20 minus 0 will give me 20. So it becomes plus 80 equals to plus 20, which is not equal. So it means this is inelastic, this is not elastic. Okay. Same goes for this one. 80 was there equals to, this is 10 positive and then minus positive 10. So 10 and 10 will be 0. So it will be 80. Basically, it will be 80 equals to 0, which is not equal, which means this is also inelastic. We are finding elastic collision. Then in the third one, check 80 equals to 0 minus minus 20. So 0 from here minus this. So this will give me what? 80 equals to plus 20, which is not equal, so this is also inelastic. But the last one, check 80 is here, so 50 is right here, minus, and the other one is minus 30. So 50 minus minus 30 is actually equal to plus 80, which is also on the right side, so it means this is elastic collision. They have to be same. Get it?
Yes, sir. I get it. Thank you.
All right, good. Caroline, Emmett, Shazib and Zain, do you also understand this? Any questions now before I go to the next type? Okay. Okay. All right. Now, the next thing we're gonna do is basically the type 2 question, and now this one is the most important because you can actually make a mistake here, as this is a trick question actually. So let me just tell you how to deal with this. So type 2 question basically comes along when suppose you have x and you have a speed here which is v, and the other one is y, and the speed here is 0, so it's at rest. Okay, now they say the spheres collide elastically. The spheres collide elastically. What would be the possible values of velocities afterwards? This is the question. Okay, they've again given a table where they've said velocity x and then velocity y, and then they have given the answers. So a is like plus half v, half v to the right, half v to the right. Then part b, where they have given v to the left, they have given 0. Part C, they have given negative half v, half v to the left and half v to the right. Part D is where they've given 0 and v to the right, like that. All right. So this is the very similar question. Like you might even see that it has even the same type of paths in it. So this is given in a table, and you want to check which is an elastic collision in this. Okay. Now, again, the first step, which should always be taken, is that you assign the directions. Okay, because it is the most important thing. These are all vector quantities. So suppose I'm taking this side as positive, this side is negative, which means this will be positive, this will be nothing, this will be positive. I'm going to put on every single value that I find. So this will be negative, this will be negative, this will be positive, this will be positive. So I have to put it everywhere. Is it clear? All right. All right. Now, so then let's look at it by putting the formula. Now our formula is u1 minus u2 equals to v2 minus v1. So this is our principal formula that we need to use. Now with respect to this, if you look at the first part, you see that the initial v1, so this was u1, this was u2. So u1 is v and u2 is 0. So it means on the left side, we will always have only v. V minus 0 is v, so v. Is it clear, everyone? And with respect to this, I want to check all the values on the right side because I want to see if it's elastic or not. Now, in the very first part, you might understand that it's basically plus half v. So I'm going to write v2. This is v2, by the way. This is v1. So v2 is half v minus the other one is also half v. So it comes out to be 0. So that means that this is not our answer because it automatically cancels out, right? Then, okay, so this whole thing becomes 0. That's why. Okay. Then the next one is V2 is 0, and then minus and minus V, because 0 minus is right here in the formula, and then V1 is V. So 0 minus minus V will be V equals to V. So this could be the answer. Now here I want to basically tell you something. Write a short note here. Do not stop until you have done the same for all parts. Now, why am I saying this? Because most of the people would actually take it like this, and they're like, okay, let's basically finish it here because I found the right answer. Now, the reason why I'm saying this, you do not stop, is because when you check the next one, you see that this is what, plus half V. So I'm going to write plus half V minus, and the other one is negative half V. So I'm going to put negative half V. You see, in this part, it will be V equals to half plus half V is also V. So both on both sides, like this whole thing was also V, this whole thing is also V. So this could also be the correct answer. So now we have multiple correct answers in this, and this is the catch of this question, that you do not stop at the point, at the first point that you think the answer is, or you found it. You have to check everything. Now let's check the last one. Last one is V, positive minus minus 0. Oh, sorry, 0. So V minus 0 is also V. So it means this can also be the correct answer. Now we have 3 correct answers by, checking, and only 1 wrong. So basically, it means we have to do something else now to figure out which is the correct answer amongst the last 3 that we found. Is it clear, everyone? Zain, Shazeh, Fatma, Afan, Caroline? Quickly, please
Yes,
tell
sir.
me. And about, yeah, and Abdullah, Ahmed Nawaz, everything is clear. Should I go forward now? Now, this elastic and inelastic is tricky because once you've done this, now I'm just going to write if there are multiple correct answers, you now check momentum, because whatever happens, momentum cannot go wrong. So basically, every collision must follow law of momentum. This is not the law. So elastic and inelastic can give you multiple answers, but momentum must give you the same. So they are identical. So I'm just putting M here. So I'm just gonna, A is completely wrong because I know it was not even elastic. So rest of them I'm gonna check. So the momentum equation for B, I'm going to check as m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. We already know this is the equation. Now, so the first sphere has mass m and the speed was v right here. So I'm going to write v. The second one has mass m, no speed. So on the left hand side, whether it's part C or it's D, the one we are checking, it will always be MV on this side because the left side is fixed, right, already. So we're going to check on the left side, this should be MV on the other side as well for the part to be correct. Now for B, you might see that it was M and V1 was minus V and the other one was mass V and it was 0. So you see here, we are going to get mv equals to minus mv. This is not possible because momentum shall always be conserved. So it means B is the incorrect answer. Now you check the next one. You say C, which is m times minus half V plus m times plus half v. So if you see the moment they will cancel out, it will give you mv equals to 0. Again, this is incorrect because it breaks the law of momentum and that cannot be broken. So C is also wrong. D should be the answer, but let's check that as well for our own self. So it's going to be mv, m times 0 plus m times v. So you see now I got v mv equals to mv, and this is the right answer because not only it follows this equation correctly, it also follows the law of conservation momentum correctly. That's why I'm going to pick this answer in my MCQ. Yes, any questions, please let me know. If you want me to explain it again, I can also do that. Now, this sort of question, like you will not find this information in any book, in any notes. I just want to tell you to make sure that now when I give you the to practice it, you are supposed to practice this again and again because this is something that requires you to you will lose a couple of marks in the exam. Now, one more thing that I would like to tell you is, if you notice, this is an MCQ, like I said, but you might have seen that it took like 4 to 5 minutes for me to solve. Now, you might be wondering, how can we manage this much time in an MCQ paper, which is paper one, and with these sort of questions where we have to, do the hit and try for multiple times. Basically, in the 1 hour, 15 minutes paper, you guys need to manage time. For example, there will be some fact questions. Like they will ask you what is meant by force. So you basically quickly do it in like 1 second or 2 seconds, and then you have to make room for these type of questions which will always be there in the exam. Otherwise it's going to be very, very bad for you. All right, so MCQs are very important to important for you and the grade as well, so please understand this. Anyway, now going to the next, I hope you guys have written this. Fatma, you cleared about this 100%?
Yes, sir.
Okay, now the next. Now, the last thing in this chapter would be two-dimensional momentum. Now, I wanted to do this, but I'm not gonna basically continue beyond what we have done because I want to basically go make it a bit slower now. We have basically covered almost like 30-40% of the syllabus. I just want to make sure that you guys are well prepared for your schools when they start, when you're doing this. So we're going to do it in the next class, but I'm going to give you an assignment today within the class. I will be sitting here. The moment you get stuck, please let me know and I will help you, and then you have to submit and I'll explain it to you. So wait a second. There will be, it's an assignment that is that also has two-dimensional momentum in it, but you don't have to do that yet. You can skip it and we can do it later when we finish the chapter. Wait a second. So momentum question will always be there no matter what. So make sure that you never skip this. There should be something dynamics written. Wait a second. Dynamics. Okay. this will be momentum MCQs. Okay. So kindly start this. I'll tell you which questions you do not have to do. When you go there, you will see. A second. You see this. Stop the recording. Wait a second.